Welcome. Today we will be discussing section 2.7, identities versus equations, as well as elementary trig equations, specifically sine and tangent. So what is an identity and what is a trig equation? An identity is always true for all real numbers. Meaning it doesn't matter what the conditions are, they're innately true. Whereas a equation they are true, but not always true. There's conditions. So equations have conditions. An example is how we could say that arctangents of tangents of x is equal to, or we should do theta, is equal to theta as long as theta is within negative pi over 2 to pi over 2, exclusive of the negative pi over 2 and pi over 2. If we were inputting, say, if theta was 2 pi, we would encounter an issue because we wouldn't get 2 pi back. We would get 0 back. And so that's the difference where an identity is it's always true no matter what happens. Like sine of theta is equal to sine of theta plus 2 pi. This happens regardless of what theta we input into this function. It'll always have that. So keep that in mind when we talk about elementary equations. So for the elementary tangent equation, we have for y equals tangent of x, then all solutions are in the form of x equals arctangent of y plus n pi. So now we're generalizing to where instead of getting a specific angle, we're going to say every possible angle that could get us this x value. So now x is not just a single value, it's more of a solution set. Okay. Well, let's look at now solutions for sine and cosine. We have y is equal to sine of x, or y is equal to cosine of x. And if y is not in this specific range from -1 to 1 inclusive, then no solution. if y is equal to -1 or y is equal to 1, then we have one base solution. If y is somewhere between -1 and 1, exclusive of -1 and 1, then we have two base solutions. Now, this shouldn't be too surprising because when we are looking at the graph of sine, we had certain values where we needed to select two different angles and then add 2 pi n to those angles to account and get every single solution. But for certain special points, we could get only one solution set or base and then add pi n to that value to get all the solutions. And so this is a bit of a kind of mirror of that relationship. But so let's first explain sine with the elementary sine equation, and then we'll look at some examples. So we have, when choosing from -pi/2 to 3pi/2, exclusive of 3pi/2, as the preferred interval, and y is equal to sine of x. So we're working with the base sine function here. We can then say that if y is not in -1 to 1, no solutions. We then have no solutions if it's not within the range of sine. If y is equal to -1 or y is equal to 1, then our base value, or x naught, is equal to arc sine of y if y is between -1 and 1 exclusive of -1 and 1, then x naught is equal to arc sine of y, and x1 is equal to pi minus x naught, or the same arc sine of y. And so how do we get all solutions? We'll state that all solutions to a given y, x is equal to -1 to the k arc sine of y plus k pi. So in other words, what happens is we can take a value here, and if we have a positive even k, then this negative goes away and we go around half the unit circle, or fully around the unit circle, I should say, and we get the positive answer. If we have a odd, then we go around halfway the unit circle, but then we have to make a negative answer here as well. And that will get all solutions. But our base solutions of x naught and y naught, these will land within this interval of negative pi over 2 to 3 pi over 2, including negative pi over 2, but excluding 3 pi over 2. And that's where these will always land. So, example. We have find all solutions of sine of x is equal to 1/2. Okay, well, we can start with this form and say, all right, x is equal to -1 to the k arc sine of y plus k pi. Well, what if we can substitute for this y and put it in 1/2 here. We can look at our unit circle or any table. I highly suggest that you get comfortable with knowing common angles, and we can say that x is equal to -1 to the power of k, and arc sine of 1/2 is pi over 6 plus k pi. And this would be our solution to all of them. Now, if we want to find our x naught and x1, well, let's plug in 0 for k. So x naught is equal to -1 to the 0 power times pi over 6 plus 0 times pi. Well, that cancels. -1 to the 0 power is just 1, so we can ignore that as well. And we just get pi over 6. x1, we could get one of two different ways. We could use the formula over here and just say pi minus x naught. And we can say pi minus pi over 6 is equal to 5 pi over 6. Or we could plug it into our formula here and plug in 1, which if we do that, we'll have x1 is equal to -1 to the first power times pi over 6 plus -1 times pi. Okay, and we then get this value, x1, to be equal to, and we get negative pi over 6 plus minus pi. Oh, sorry, this is 1 here. This is supposed to be 1. Yeah, that's why that was makes sense. So plus pi is what that should be, which then pi minus pi over 6, that is 5 pi over 6, and we get the same value. So this is our all solutions here. And this is in the form that we'd want it. Note k is an integer. You could also use n, It's just a placeholder. But denote, and I should be scrupulous and put k is an integer. Come. And so if we want to plug in a -1 or a -2, we could do that as well. Or we can go further, but here is our base. And notice they're both within our preferred interval. Okay, so thank you for watching. Your check on learning will be to write down the all solutions to a elementary sine equation. So just write down this formula here. And thank you for watching and have a great day.